So for yesterday's one, I have uploaded this document. Date-wise, you can see, I think I should made it with some numbering. This one I uploaded yesterday. Handling complex data types and custom transformations. What we did yesterday and day before yesterday. Okay. And code for the same is this one, PySpark, ODF and functions. This is also uploaded over 30 January. So you can take both and you can do that. Okay, then I will move to next. Here, join we discussed, and then SQ joins. I believe that about SQness, SQ data, SQ issue, you people are good now, right? Anyone has any question there? Because that's the thing you should know, and you should know properly. That's what I can say, because that will be the part of your interview question most of the time. Not 100%, but it will be. I think
Yes,
no revision or you have not did.
theoretically it's okay.
Okay, then fine. Then as a single line, you can just see the syntaxes as well. Okay. Okay, then let's do for this Spark optimization. For the Spark optimization, we have few options which you can take care for the optimization part, because you know you are if you are a good developer, you will know how to write the code and what to do about the logic implementations and all good. But at the last, is your application is really compatible? Is that really fine? Whatever you want to do, that is okay. Okay. So like let's say you are doing something and maybe you are intended to complete your task, your job running within 15 minutes, but it is taking some 20 minutes, 25 minutes. Can you optimize that much better? Because most of the time, let's say you are getting the data from the source and the data is coming with some frequency. Let's say that frequency is around 10 minutes or 15 minutes. So it's better if your application can complete the processing of previous file before next one is coming, right? So there will not be any lag. If still processing is happening and it will be taking some more time, and one file already landed, the next file, in that case there will be lags, keep on adding the lag, previous files and upcoming files and all, and then there will be a burden at the end of the day, that this much remaining file still have to process. So if we can make application which is running with the time and it is not keeping anything lag because of this processing times and all. So that time, even your application is good, you have written the logic properly, you are getting the expected output. But after that also, optimization is required. It should be running with the time. It should be running with the limited resources. It should not take lots of resources. Let's say lots of resources in the sense, if you are working with on-premise cluster, you are having some 50 node cluster and you are utilizing 20 nodes. Your processing is happening completely fine. That is okay, because that is a pre-investment. Means before setting up all the jobs and all, investment is already done over the Hadoop cluster, big data cluster, wherever Spark is installed, and you are running over there. So either you use 20 resources or 10 resources. It matters only if someone needs that resource. If resources are free, you can use that because there is no additional cost for that. But if you are working in the cloud, then in Edge, let's say Azure, you are you actually need 10 nodes for processing, but you are utilizing 20 nodes. Then what? You are going to pay double bill, right? Double amount. So unnecessarily, we should not utilize the resources, memory, or everything, because you are going to pay for each and everything. Nothing is free in the cloud. For on-premise also, that is not free, but the thing is that is already invested. So if that is free, you can use. But in cloud, nothing is free. Even for a single second also, if you are going to utilize that, you are going to pay. So these things have to keep in mind. So our job should be properly optimized. And if you are going for the interview for the Spark architecture, Spark transformation, joinings, and Spark optimizations. These are the questions which will be must. Okay, if Spark architecture and optimizations you can't neglect in a 90% interview. These will be there. So you have to focus here. Here, optimizing Spark job is a crucial for handling large scale data processing efficiently. As we already discussed, if you are having a small amount of data, there is no issue. I will say from my previous experience, once we were working for a data set where we did the POC worked very much fine in the on-premise. Then same data got migrated to Azure. And code was written in the Java. That time Java was means we had Java resources and Java was in trend. That time Python was very less in terms of PySpark. It was not either Java or Scala. So that was developed in Java. We were getting completely expected output. That was a very complex coding because complex requirement was there. But finally, when that same job, same code got migrated to Azure cloud, then we started getting millions, billions, and trillions of data file with that much volume. What happened? Code was completely fine, but it started getting fail because of out of memory exception, because code was not handled in a way that it can take care of that. That means code was completely fine. It was running for a year in on-premise with some less amount of data, and no one got any issue. Everything was working fine. Then people think that okay, this is completely okay. Then just migrate the same code to the Azure, and it will be working with big data amount as well. But that started failing at the first day itself. It was not able to process the data with the same resources and the same amount of each and everything whatever we had, just because input file was increased. What happened? That got failed. Even that code was not good to optimize because that was in Java. That was very complex. So simply again 2 or 3 resources got allocated to the same, and they did a fresh development using Scala and with some enhancement, some additional things how they can handle that things. And then it was made properly to run all the things. What they did, they focused mostly on the optimization part, how much they can do the filtration, how they can handle the failures, how they can uh, think about the file formats, how they can think about the persisting, how they can think about the shuffling, how they can reduce more and more data shuffles and all. And finally, it worked fine for it. The data was around terabyte, I can say. That's what that issue happens. But terabyte data is really a very crucial amount of data, and we have to always be ready for that. So my point was mainly whatever you are developing, that is good for handling less amount of data. That is always okay, but you always focus on what if tomorrow data will be double triple and it will be kind of multiple GBs, TBs and all. Then will your code help in the same way? If not, then what else you can do more better? That you should always follow that. Okay. So here what we can think about first is using data frames over data and data sets over RDDs. So here I have categorized that. Okay, this is data frame and data set optimization. So using data frame and data sets over RDDs. If you are working with the RDD, then that's the native structure for the data. If you are not converting that in the forms of RDD or sorry data frame or data set, then by default that is in the nature of RDD only. And RDD is a low level API, right? If you are comparing with data frame and data sets. So in all the way that would be costly if you are comparing. So data frame data sets leverage Spark Catalyst optimizer for query optimization, while RDD lacks optimization. And as this is low level, this is high level API. So these are always better. These are much optimized. They are having some internal optimizations aided by the Spark community as well. Means that is much more optimized. So that is going to help you a lot. Like here it is saying instead of rdd.map use dataframe.select. So that will be more better. If you are converting the data to the data frame and then you are using select option. Then avoid wide transformation over narrow transformations. We have already discussed this, and here single line statement is avoid data shuffle. In narrow transformation, all the things happens with the same partition, single partitions over the node, and with wide transformation that needs to data communication between the either if you are having two nodes, then between two nodes. If you have multiple nodes, then amongst all the nodes. So it needs to communicate with the data amongst the nodes. Okay, so if you can avoid wide transformation, you should always think about that. So narrow transformations like map or filter are more efficient than wide transformations like join or group by, as they do not require data shuffling. But always we can't ignore wide transformation, right? Let's say you have to join, you will be always joining, you can't avoid. But what you can do better, before joining, if you have to filter something, then don't think about I will do first join, then I will filter. That's bad. First you can do filter, then you can do join, right? If you have to remove some columns and all, you can first do all those manipulations, all those operations, then you can go for the join. So keep those whatever better part you can do for the which can reduce your data amount, which can do something better and which can help for less data shuffling. You can first follow that and then you can go for wide transformation. Then here using select over with column for adding the column. Like if you have to add the column, we had already seen this in the our white transformation exercise. Using select also you can add the column like right, like dot select, you can say column A, column B, then column concat column A plus column B as column C. That means you simply using concatenation you added one more column also, right? So that you can do. And if you are doing with column, then with column also you can do the same. The one thing is for each of the new column, you will be having multiple additions, multiple that many time you have to do with column. And again internal operations are different. So it is saying that with column creates a new column by making a copy of the data frame. That means if your data frame is having some 1 GB data, then this is making a copy. That means 1 GB more data, 1 GB plus 1 GB, now it is having 2 GB. So how many times you are using this with column, this is going to make a copy for the data frame, while select optimized for the column projections. So for any column level things, you can think about select or select expression over with column. Then here you can see the example df dot select first column name. Then for second column name, I wanted to add a column age plus 10 and age new age. This is the new column name. So alias name I provided. So this is helping. Without with column, you are good to add one new column with the logic, whatever you wanted to. So like that we can. Then minimize shuffles with partitioning. Reduce unnecessary data shuffles by partitioning data properly, especially when performing join or group by. Okay. Then use repartition to manage data distribution, where we can say df dot repartition, then partition number, then column group by count, so and all. So you can do that. So we can minimize shuffle with partitioning. Here you are going to do repartition, and repartition is always better. And you know why always better? Because first of all, this is going to care about data distribution. That data is evenly distributed over the nodes. And second thing, parallelization. If you are having 10 nodes, you have allocated 10 resources and your partition is also 10, then each one will be processing for one. No one will be in queue, or no one is sitting idle, or no one is in waiting stage, right? So that is going to help without having any queue waiting and all. Then avoid unnecessary column operation. Avoid computing expensive columns multiple times. If you have something, then what you can do, single time you can do, and even you can go for caching and all. You can cache and you can reuse if possible. So cache computed columns instead of recalculating them. You can simply cache them and then you can reuse. Like where with column, this is your expensive column, expensive computation, whatever logic you are having. Let's say this is a UDF and you have defined a function, you registered as a UDF, and then here you are calling that UDF, and with that you are getting all the calculations and all. You did this expensive column. What you can do, you can finally persist that, right? And then sorry, persisting is something when you have good amount of data. If that is fitable to memory, simply you can cache and you can reuse that. Fine. And then predict push down, predicate push down. So if for this predicate push down, use predicate push down to post filtering operation to the data sources. Let's say you are having 1 TB of data, and from 1 TB of data, uh, let's have example that 1 TB data is containing some countries data, some 50 countries are there, and you want to do your analysis for some 5-10 countries only. Then one option is read 1 TB of data and then using select do the filter. Then at least for the first time, complete 1 TB data should be loaded into your system, and it need that much volume at the time, right? While you are reading, while you are loading that. But what you can do while reading itself, do the filter where age is greater than 30, or country name equal to this country name in. We have the SQL statement, right? So if you are doing like that, then if file is 1 TB, this is not going to load 1 TB. At the reading time only, this will be filtering the data, and whatever is within the criteria, whatever we are defining, that will only be coming here. Then column pruning. So select only necessary columns to avoid reading unnecessary data. If you are having 100 columns in your file, let's say you are reading a file.parquet, and that file contains some 50 plus columns. Do you need all the column? Really? If you need, then okay. If you not, then why you are moving around all the columns? Not needed. So you can simply do column pruning, select only necessary columns to avoid reading unnecessary data. Then you have like here you can do dot file dot parquet. You are reading the file, and during file itself you are selecting whatever you really need. So you apply the filter, you apply whatever selection you want, and then you go ahead. Then optimize joins with broadcast. If you are having a small file set, if you are having a bigger file set, then why not to go for the broadcasting? You can broadcast the smaller data set over the nodes, and then it will avoid shuffling, and all the things will be happening at the same place. So use broadcast for the small tables to avoid costly shuffles during the joins. How you can do that? Simply you have to have this keyword broadcast while you are doing join. First data frame means large data frame dot join. Within bracket, we are going to have this keyword broadcast, and then your small data set and which key you want to. You have to give that. Then next optimization you can think about map partition instead of map. If you are using map anywhere, then if you have the opportunity, you have the things that you can use this, you can go for map partitions also, because map partitions works on a partition level, and that is going to make it more efficient than map for the larger data sets. Okay, this is the syntax for the same. Then caching data frame to avoid recomputation. If you are going to do some complex calculation, then and that same calculation you are expected to do some 3-4 times or multiple times. In that case, first time you do that and then cast the same and reuse that instead of recalculating the same thing, because recomputation will be always occupying memories and resources and all. But tell me one thing, let's say I calculated and my resulted output was 4 GB. I did the cache. Uh, as a benefit, we are going to avoid recomputation. That is okay. But is that taking anything additional to the resources as per your understanding? Anything? You are getting my point?
Yes.
What is the point?
Apart from this, is there any point for optimization which you can
No. So my
basically
point. Go ahead.
you can.
No, my point was, let's say you are doing some recomputation. So for you are simply doing caching and then you are utilizing that. Then you are avoiding recomputation. That is fine. But what output you have cached, that is around 4 GB. So that 4 GB is the additional memory utilization by your job, right? Application. Until
Yes.
unless you cache, you do unpersisting, that data will be stored somewhere. Means that needs some memory. That output is stored, and whenever you are just reusing that, then same output you are going to reuse. But until unless you do unpersisting, that memory utilization will be there. That data has occupied that much memory, it has reserved that much memory. That's why when you think that I am done with the utilization, reusing and all, and going forward, this is no longer required. Means in next further movement of the application, this is not needed. Then at the point you feel that this is no longer required, I am done, and whatever next transformations are there, this is not going to play any role. Then simply you can do unpersist, right? If you are not doing unpersist, then until unless the application is running, this data will be moving around. If anything is happening, that is also going to play a role, and that is also data movement for that 4 GB will keep on happening. And that is again one issue means processing time. It will be increasing the processing time, that is going to take some amount of memory also. So that's not good. As this is good for the avoiding recomputation and saving the time for the complex algorithms and all. But as soon as you are done, don't forget to unpersist that. Then second thing is partitioning and resource allocation. Here you are saying df dot repartition 100 and use repartition to increase or decrease the number of partitions for better resource utilization. Let's say you are submitting a Spark application using Spark submit syntax, and you have given some 10 executors and 5 cores. That means your total resources are 10 into 5 equal to 50. 50 resources you are having available. You have to process the job. What do you think? Uh, for making parallelization in the sense each resource should have some data to process and no one should sit idle. And even you can take care that no one is having overburden or less amount of data. What will be the best practice for you?
Decrease the partition to
How much?
50 only instead of 100.
Yeah. So in that case, if you are keeping 50, then each one will be having one and they will be good to process. And if you are keeping 100, then what will happen? 50 it will be processing and 50 will be in the queue, right? Until unless first one get completed. So if you go to the Spark UI and you do just debugging, I mean, so just you see the at the processing time, just to monitor that what's happening and how this is processing. Then you will be seeing that what is in the progress, so it's processing, and what is in the queue. So that will be your processing will not be completely parallel. That's why it better if you can make the partition number according to the resources. Then Coalesce and reduce partition. Coalesce and repartitioning both are used for increasing and decreasing the partitions, but repartitioning is good if whenever you are thinking about increasing the partition and you are making sure that data distributions are equal, means even a similar volume of the data. And Coalesce when you are not caring about the volume of the data, either that is even distributed or not. Simply you are thinking that okay, I have some 50, let's say here you made 50. So 50 repartition you had and you did all the processing. Finally, you want to write this output data as a Parquet file or as a CSV file, whatever is your expected output, and you are looking to write as a single file or two file or five file maximum, then you can go for Coalesce and you can define the number. So this is good for reducing, means decreasing the number, decreasing the partition number. Even you can use for increasing as well, as I said, but both are having its own benefit for the data distribution and all. That's why for increasing we choose repartition and for decreasing we choose Coalesce. And this is one of the favorite question for the interview, difference between Coalesce and repartition. So make sure that you are clear with it. Then
Anamika,
use,
one doubt.
yeah,
I think by using Coalesce, we can only decrease the partition, and with the repartition, we can also decrease and increase the partition.
no. With the Coalesce also you can increase the partition. You want to see a demo? I can show you. So see, the thing is here simply dot Coalesce. Let's go here and I will create a new class. I need a data frame. So I will simply copy this. Data frame is ready. Then df dot df1 equal to orders df dot Coalesce. Let's say 5. Okay. Now I had said you one syntax to check the number of partitions. Anyone remembers that? What was that?
Get number of partition. Get number of partition.
So print and then get num partition udf1 dot rdd dot get num partition, means that is a RDD operation. Okay, so you can't apply directly over the data frame. If I will do this, then this will fail. Let me run this. So here let me make orders df equal to orders df dot repartition. Make it 50. So original is 50. If here I check, this is, let's take first, then orders df dot rdd dot get num partition and then make that as 2. What you say? This one. This is not acceptable because data frame object has no attribute get num partition. This is an RDD operation. Okay. So I will come back to the RDD and I will make one more. Let's say this one df2 equal to df2 equal to df1 dot Coalesce 10 3. Let's run this. Okay, this has made it is constant, right? 5 5 and
Earlier is 5,
5.
so it not
Yeah, so
increase.
in df1 we made it 5, so this has made it constant. And again, if I take one more, let me just try it out because we have not tested this much. Means we do not get the requirement for this much testing. Okay, Coalesce 10 and let me make it. Okay, anyway, this is not reducing. So let me do it repartition just to test. Repartition, I'm making it 20, 10, and here keep 4. You want to put one more condition for the testing here?
In line number 54, we already have DX10, na? So we can increase 54.
54. You okay, you want this number?
No, in DF dot partition, we mention it 10. So we already make it 10 in line number 51. So either we need to increase or decrease.
But that is making constant, no? For Coalesce, part number 3. Okay, okay. This was the issue. Sorry, I didn't. I saw this one. I had just simply did copy paste, right? So for orders.df, first I did the repartition. So my initial partition is 50. Then df1 orders.df, we are doing Coalesce. And for Coalesce, it should be 5. Then df2, with this from this 5, we want to change the partition to 10. Then check the partition and again df3 to the repartition to 10 and check here df2. Just this is not required now, right? Or simply we can say let's take this as well. Again I will do Coalesce 1, simple df4 and then df4.
Line number 55 is
Sorry?
line number 55.
Huh?
It should be DFP now.
This one?
Dot RDD dot 55.
Uh, this is df2. This is wrong.
In line
Okay, yeah,
number
this is wrong,
54,
Ryan. This is wrong. Yes, yes. This should be df3.
and line number 50.
And this should be also df2.
Yeah.
Right. We should not do copy paste. Copy paste is having something. If we forget, everything will be messed up. Okay, now we can see here. Initial was 50. Then we did Coalesce to 5. We are getting this. Then df2 we did Coalesce to 10. It is increasing also, right? From df1, this is good to increase. This is increasing also, this is decreasing also. Then df repartition 10. Again repartition was 10 static. Even I could have do 15. And then again Coalesce 1. And this one also I have put 5 only. So yeah, this Coalesce and repartition both are good to increase or decrease. Only thing is when we are using which one. So repartition we can use whenever we have to process. So our data should be distributed equally. Coalesce means we are not going to process data again. Means further that is not the requirement, and only we are going to save the data as output and all. So processing is not considered, and that is really not required. Only we have to dump the data finally. So this Coalesce is okay. Here you can see, so there is nothing like with Coalesce you can only decrease the number and not increase the number. But in real time, that's not a good practice. We never follow this. That for increasing we are going with this number. For decreasing we always go.
Yeah.
Fine. Then come to next. Here use partition columns in the data source. So partitioning tables by specific columns, let's say you are having a date column, help avoid scanning unnecessary partition. Let's say you are having a data or you are having a data frame that contains data for the 12 months. If you are looking for a data analysis for last 3 months only, what is the need of going for the entire 4 months? So you can make sure that you are scanning only the required data and not unnecessary. Another thing you can take about is queue data management. This is a valid question, and you will be facing this question a lot. Maybe sometimes what you can get the question, what is the issue you faced in your project? This is a famous question, right? That means people want to understand if you have faced any challenges, and if so, what was your take there? How you resolved that? So SKU data is also one of the problem which you may get in your production or maybe in your lower environment only. Then what was the issue and how you handle that? So handle SKU data by repartition or using salting technique. Salting technique we discussed yesterday, how you can create some a key with the uniqueness, and then based upon the key you can redistribute the data. So either you can go for some repartitioning or you can use the salting technique for joinings with this Q key. How you can do, if you are going for the salted key, then you are creating a key with some, let's say here the concat with some random key, and then based upon the key you can further go with the further activity. Then optimize resource allocation. And okay, so here in SKU data, one more thing happens. Let's say you are writing some transformation, and there you are having a partition by this column. You are having a transformation. So let's say you are saying partition by year. So partition by year maybe for some year data is different, for another year data is different. And if there is some more columns, so partition by year, partition by country, or partition by cities. So you can take care for some optimizations with partitioning also. If partitioning can help you to get some equal amount of data, if that is helping, or if you have some key column which can make sure that if no, data is not completely equal distributed, but still you are getting some 60% 40% ratio, so near about that is not going to block you or having a bottleneck kind of issue. That also you can think, but if that is not helping, then you can go for the manual intervention with salted key and all. Then optimize resource allocation. Optimize resource allocation in the sense, whenever you are going for the Spark job submit, then you are saying Spark submit and then giving all the things, right? Like number of executors 10, number of cores 5, executor memory 15 GB, driver memory, let's say 8 GB, 10 GB, whatever you are giving. So you can optimize that, and for the optimization you should have proper understanding about your job, that how much partitions you have allocated, and how much data amount is, and by default how much memory it is really required to process the data. And again, what is the time expected? Time expectation is something, let's say you and me both are running 50 GB data, okay? And for that 50 GB data, your requirement is that your data should be completed within 30 minutes itself. My requirement is that that is daily data, and I am getting once in a day, and I can process anytime, even morning, evening, or it is taking 6 hours, doesn't matter. and we are having some limited resources over the cluster. What we can do, I can allocate 5 executor only for my job, because I can take even 6 hours also, 8 hours also. I am not in a hurry. And as your job is really critical, amount is same, maybe logic is also same, but timing is crucial here. For you, it should not go beyond 30 minutes, because maybe next batch of data is in the pipeline that is coming for the processing. In that case, I can share some resources with you, right? I can say, okay, I am good to process with 5 executors only. I am allocating this for my job. And for you, if you are going for, let's say, for example, I am also having 10, you are also having 10, 10 plus 10, 20. I can allocate 15 for you, and 5 for me, or some 17, 18 for you, 2 for me, because your job is crucial, right? For the time processings and all. So like that, we can also think about the resource allocation based upon the criticality. That which is what is the priority, what is really need, and based upon that we can increase and decrease. And another thing is you should have proper analysis that what is the amount of data by default, what all persist partitions are getting created, and for making the parallelism, whatever partitions you have allocated like repartition or Coalesce or whatever, then how much resources you really need that is going to benefit you for parallel processing plus timely uh, job completion. That your application is going to complete the processing on time. Then you should always be aware about this optimization for the resource allocation, and this helps a lot in the cloud computing, because in cloud if you are blindly doing this, let's say number of executor 10, you are saying 15, then unnecessarily you are going to pay a good amount. That's the waste of money. Unnecessary billings will be there. So that is not needed. Always you do your proper analysis, do all the things that how much really needed, then only you go with that. Again, one thing is there. Let's say we are doing a Spark submit. Okay. With this Spark submit, you have to process 50 MB data only. What do you think? Are you going to give this and this will be helping you? Any idea? Let's say notepad. I am going to give this Spark submit. Okay. And simply I'm saying this, let me copy this. Okay. And your Python file test.py. Let's say this. Your file size is something 50 MB. And here I am saying number of executor 1, core anyway not required, but I'm giving 1. And here I am saying 50 MB. What do you think? This will work or this will fail?
Able to see your screen.
Hmm?
Think screen sharing stop.
Okay. I will reshare. Let me know if you are good to see the screen.
Then now able to see.
Okay.
Able to see only this Skype.
Yes, I am not moved to the notepad. So my point was, here you are having a Spark submit. Okay, let me check one thing in the Skype. That is okay. Here, for the Spark submit, you are having number of executors 1, course 1. Your file size is 50 MB only. And I am saying executor memory 50, 50 MB. What do you think? This is going to run or this is going to fail?
PMB only, and also
And even let me tell here,
60.
hyphen
Yeah.
hyphen driver memory. And the driver memory also I am saying 50 MB something. Just I am giving according to the job. So my question is, will this fail or this will success? Because your file size is 50 MB only.
It will success, but some maybe presence of performance issue.
No, this will fail. You know, in this Spark job, first what's happen? If you as soon as you are submitting this will be starting a Spark session from your application, right?
Yes.
And this after this Spark session, this is making the connection between the driver node and worker nodes. Then resource manager is there that is caring for all the allocations, how the job should be allocated, where the task will be, and which worker node this is going to run. So this itself needs some memory before taking care of this file. This file will be coming later in the picture, right? First Spark
Yes.
session is going to be initiated. This is going to make the connection between the nodes and all. So this needs some reserve memory. So minimum you should keep for the safer side, you should keep at least 512 MB memory. Okay. So it will be having some reserve also, and this will be not failing. So here what I can say, if I am giving this one 512, 512, let me keep this one, and for executor memory also 512 MB. So 512 MB is something I am allocating for this, and my file size is 50 MB only. Then this is how this is going to there are some reserve system memory that is around 300 MB. That is just utilization by Spark session and happening making the connection, and means just making up your system. You are going to have if you are allocating some 10 node cluster or one node cluster, whatever, then first this is going to initialize that, right? By making that up and running, then only your application will get started. It will be good to run there. So this is just preparing all the things, and for the further preparation that needs some reserve memory, and that reserve memory is something around 300. Okay, around, not exactly. So if you are keeping this one, this will be safe. So for the testing purpose, what you can do, keep some small file and just run with the same memory and see either that is failing or passing. That will fail. Then you will be getting the thing. Okay, what is happening actually, and how much I can give, then it is not going to fail. So here it will be keeping some reserve memory, and then available. Then remaining memory will be available for the Spark, and whichever available for the Spark, that memory only it is going to use for the processing. So what happens, let's say you are saying whatever executor memory you are giving something, let's say 4 GB. Okay, then reserve memory out of this 4 GB, this is going to have some reserve memory. Reserve memory, let's say this is coming up by around 300 MB. Then available for the Spark. Uh, available for Spark is if you remain 300 MB after doing minus 300 MB, we will be having around 3.7, right? 3.7 GB remaining balance. And here, whatever available with the Spark out of this memory, that memory will be getting used for your processing and storage. So execution or processing and storage, that will be in use. That gets used by around 60% as per Spark definition. Okay, and then user memory that is getting used by 40%, remaining 40%. So this is from out of this 3.7 GB. So out of 3.7 GB, 60% this is going to utilize for the execution and the storage, and 40% this is going to use for user memory. And then memory overhead, because memory overhead is also required, no, whenever there are some additional need. So let's say memory overhead. Memory overhead, let's say some 10%. Okay, we should actually, this is a good practice that we are keeping some memory head also in our application. That is for additional memory, you can say. So this is your complete 4 GB. If you have allocated 4 GB to the executor, but sometimes you can think, okay, my file size can be 4 GB. My file size can be sometime 4.5 GB also, and sometimes it can be 4.5 GB, and sometimes it can be 3.8 GB also. Means near about, right? So if you are allocating 4 GB and file size is 3.8 GB only, your job will not fail. But if that is coming little more, 4.5, it will fail because of memory, right? So you can keep some memory with overhead memory. That will be helping you here. And what is the benefit of overhead memory? If you are allocating this 4 GB, instead of this 4 GB, if you are allocating 5 GB, then that will be reserved by Spark. No one can use that resource. Another application will not be using that. And if you are keeping overhead, that means that is not reserved by application, that is free, and this will be in picture only if your application really need that at the meantime uh, it got that, okay, it needs some more memory for processing, then that memory will be occupied from the cluster by your Spark application. But that is not the reserved one. Like if you are saying overhead memory, let's say you are giving some 2 GB, just I'm giving example, then this 4 GB is the reserve by your application, but this 2 GB is not reserved. If your application needs, then only this will be occupied, and otherwise this won't be occupied. Your application will keep on running with this 4 GB only. But here itself, if you keep that 6 GB, 4 plus 2 6 GB, then this will be reserved until unless it is required or not. Maybe it is working with 4 GB data only, but unnecessarily this occupied your 2 GB additional memory also, right? So this is not needed. You can plan for memory overhead and then you can allocate memory accordingly. Here we have option. Okay, you have for memory head, we have two things. You can say Spark dot executor dot memory overhead, memory overhead equal to whatever you want to give, and you can enable this with Spark dot memory dot off heap. Even that is not required, just I am giving a reference. Dot enabled equal to true. If you are simply giving this overhead memory, that would be enough for you. Okay. Okay. And here, so here one more thing you can say, minimum or maximum you can give, but that is okay, not required. This one, no coming back here. Okay, then you have Catalyst optimizer. Filter early in the pipeline. Whatever data we are getting from the source, we can think about filtering very first, then going for the further processing. So that will be reducing the data size, right? Then use explain to understand the query plan. Let's say you were running some critical and all, and you are not able to understand how it is processing in the backend, what's happening. So you can use this explain query. This will be defining all the things, and then you can plan accordingly. You can think about this. So let's run this one. I will simply run this df1. or let's say orders df, and let's run this. So if you see the plan, it is simply explaining everything, right? Like the relation, order ID, customer ID. These are the relations with the column of the JSON. Then analyze logical plan. This is the schema, and then repartition you have made 50, and then again optimized logical plan. So this is the again relation, and then physical plan, spark adaptive spark plan is final plan. Then final plan, this is the shuffle query stage. Then round in partition 50, then repartition by number, plan in this one, then file scan, whatever you are doing, then initial plan, what is happening. So as of now, we do not have anything with the orders data frame. I have simply read the file and we made the partition 50. After that, nothing is there, right? So just assume that I am having some multiple transformation over there. So I will be getting details about that as well. So if you are having some criticality, you want to, maybe you can take some decision, you can take the further things, what should be the next for the better thing. So you can do that. Okay. And then that can help you to optimize your job more. Then avoid Cartesian joins. Cartesians, we know that it is going to map each and everything by it, means each key with each of the value, like we seen in our previous examples also, that we did some that price map column, we did product and then we did the price. If we are doing simply map keys and map values, what it was doing, it was mapping each product with each price. That was wrong. It should be doing for that it's a specific price itself. This is the product and this is its price, not like all the prices tag with each of the project. That was wrong. So if you are doing Cartesian, where this is mapping each with each one, means each key is coming with each of the value, then that is going to have a kind of unnecessary data volume which will be increasing, and that is most of the time that is going to have a wrong output. And if that is the right output also, you can think about if you can have alternatives. Okay, so you can avoid that until unless this is really required, and I'm sure that you will be having one alternative for this use case. So Cartesian joins or cross joins are extremely very costly because this takes lots of time, and in result this is going to return lots of data, and most of the time that data is useless. If I'm talking about 90 plus percent, that will be useless, because if you are keeping some alternative, you can do better with less time, and you can do it very efficiently. So avoid them with less absolutely necessary, and you can do this one your cross join, right? So this is just the thing, this is just syntax. Then optimize join order, reorder join to avoid shuffling large data sets to multiple times. So that you can do, let's say you are having the small data sets, then you are having the large data sets. So what is the reorder for joining? If you are having a small data sets, if you are having bigger data set, or all the data sets are large only, or all the data sets are small only. So just a question, if you are having the SQL background, how you keep ordering for the data sets or tables? Any idea? Or you
Come again?
follow anything? If you have 4 tables to join and all the
Mhm.
tables are having multiple, means different volume, how you keep the tables in order? In which order you keep?
Small tables will join first and then ascending order you may can decide. Smallest to biggest. But it depends on the joins as well. which join we are performing.
Right. So we can think about that which is the requirement, but we can plan that if I am keeping the first join first, sorry, small table first, or I am keeping the bigger table first, that is also. Uh, but again, we can say that this is completely depending upon the requirement, because all the requirement are having different things, right?
Yes. Even we need to keep in mind that the uh, tables, whether the table is get updated on frequently or not. So this is the one that also we need to take care.
Right. So if we think about the like shuffling and all happens, right? So bigger table first we can see, we can keep, let's say if we are doing the inner join, if you are doing the left join, then bigger table will be helping you, because optimize it will be optimizing to prefer the large tables on the left, and it will be minimizing the shuffle. But when we are going for the right join, then right table drives the join. Right table is the main thing which is driving the join, right? If you are going for the right one, then larger table should be on the right side. That's
Yes.
the thing. Then your order will be reverse. Then if you are talking about full outer join, then again larger tables first, because it will be reducing the intermediate result size. So you can keep that first. If you are coming to cross join, then again a smaller table should be the first. If you are talking about semi joins, then semi joins means a smaller table should be inside for the better performance. So this orders we can make, but again this depends upon the type of joins, that how this is going to take the data as a input. So that will be helpful. And then we have partition pruning. We already understand this, that we can do the filtration when while reading the data. Then bucketing for the joins. We can use bucketing for join operations on the large data sets to avoid shuffling. Yesterday we discussed that, right, in the join, that you can enable bucket join, and you can have same number of buckets for both of the data frames, both are how many you have, and then that will be reducing the processing time. If you are going for the join, your join will be much more optimized. So you can think about that. Then avoid UDF where possible. Yesterday we did the UDF. UDF means what? Whenever you do not have any logic available with the Spark, means function, then you can write your own function and you can do whatever you want to do with the data, columns data. But this is really a costly operation. Okay. Spark cannot optimize user-defined function, so try to use built-in function wherever possible. And where this is really not possible, no option is available, then only you go for the UDF. Then optimize window function. So window functions, they can be so with window functions, whenever we are using, they can be expensive. So use partitioning widely within the window. We have o row over partition by, then order by, we were using that, right? So whenever you are doing partition by in the window, make sure that this is resulting in a better way. Means output is okay, but processing time and all is also fine. It is not taking lots of time. So make sure that partitioning you are doing properly with the proper key. Then you can think about some advanced techniques like leverage data escaping with the delta lake, if you are using delta lake. Okay. Then avoid a small file problem. A small file problem means you can think about, okay, if reading and writing, mostly for writing, because you are going to store the output. So if you are storing multiple small files, that's not good. Let's make a big file uh, with the big good amount of size. Let's say you are having 50 GB data, you can plan for 5 GB, and you can return 10 output files. You can write that. So this will be good with the memory size also. If you are going to deliver, you have to deliver 10 files only. And second thing is, your cluster is managing the metadata details and all. So that will also be not overburdening to the cluster nodes and all, because it will be less in the number. So we can avoid small files, creating small files, and that you can do using Coalesce and Repartition. And then use clustered indexing. Okay, where optimize the data layout, especially for the time series data. If you are having something related to time series, then optimize shuffle operation. Optimize shuffle operation. This is the shuffle partitions. Okay, let's say whenever shuffling is happening, this is creating the partitions, number of partitions as per Spark. But you wanted to reduce the number that, okay, make this much number only as a maximum. Then you can restrict the numbers by this setting, and this will not be going beyond that. Okay, because some of the time by default this creates some partitions, partitions during the shuffle for the white transformation. If you are applying group by and all, by default this takes around 200 partitions. That's not good even for the small data only. So I will create one simple code base and I will show the next day. Just for the 10 minutes we'll show how it is going for the UI, Spark UI, and how during the shuffle this is creating shuffling partitions and all internally. How this is impacting for the narrow transformation and for the wide transformation both. Then adaptive query execution. So this you can enable the adaptive query execution. Okay, so this is going to help you. Then join hints. You can go for the join hints for the broadcast shuffle has a sort merge to manually optimize the joins. And then tune parallelism. For that you can say, okay, set parallelism in jobs like saving files to ensure efficient resource usage, where you can say max records per file, and this is the number of records you are, means while saving the data you can decide the numbers also, that okay, you are writing a per file, but per file you wanted to limit with some rows, that one file should have this much row, so you can do that as well. And then optimize write operations, where you can use mode to append mode to avoid unnecessary overrides. Overwrite means what? Simply it will be overwriting the existing data, right? So you may lose the uh, previous data also, whatever you did. So you can go for the append. So it will be avoiding unnecessary override. Then compact small files partition. Compact small files means, let's say you do not have control over the small files, and let's say this is a streaming job, and in a streaming job the entire day it's running the job, and all the time this is creating the files, sometimes small files, sometimes average size, sometimes bigger size. So at the end of the day you are getting variety of size, in the size you are getting the varieties. So and at the end of the day you can plan for compacting, you can merge all the files, partitions and all. So if you are running at the same time you can do that. So let's say you are saying Coalesce one and you are compacting that, that's one thing. And let's say you do not have control, this you can do with the batch file only, right? If that is at the one time you can do Coalesce, but let's assume that job is keep on running 24/7, and every time this is some data is coming from the source, sometimes a good amount of data, sometimes a small amount of data. So even if you are doing Coalesce 1 also, and let's say total data was only 30 MB. So after one also, Coalesce 1 also, your file size will be 30 MB only, right? Next time you got some 500 MB, then your file size will be returning to 500, 1 GB, whatever. So if your file size is good, then fine. Otherwise, at the end of the day, you can plan for merging the file, keep on merging. You can have one of the automation, but that is again separate thing from this context. This context is for compacting small partitions, like if you are processing your job with 100 partition, 200 partitions for the better processing time, performance and all, that's okay. Just at the end step, at the end line, simply do Coalesce 1 and try to reduce the number of files. Keep some standard number, so it will be not returning multiple small files for each of the partition. Then use sorted data sets for aggregation. So sorted data sets before aggregation improves the performance. If you, let's say you are doing some aggregate operations like sum or average or max. I mean, what Spark will do? First, Spark will sort the data internally. then it will do shuffle, it will do all the aggregation. If you sort in advance, then Spark can be more faster. So better if you can do the sort. So use sorted data set. Before doing the aggregation, you can sort the data and then you can go for the further things. Here I am using df.order by key. So this is going to sort, then group by key, then aggregation, then whatever you want to. Or in advance also you can sort the data, then you can go with that. So that's some points from for the Spark optimization. Here I have mentioned some 33. Even you can keep in mind for 10, 15 also. That is going to help you. You can discuss about that. And okay, this is the part of Spark optimization document. I will upload this. I have not yet uploaded. Okay, and then these are some Spark configs. Okay, I have mentioned a lot here. You can go through it and you can one line is there. You can read about that. This is helpful whenever you are thinking about Spark executor memory. Then simply you can say spark.conf.set. If you have set up in the Spark submit, then that's fine. But let's say that at the code level with the Spark configuration, you wanted to have the changes or you want to set up there itself. So you can go for that. For driver memory, you can do this. For executor code, you can do this. For the shuffle partition, if you think that shuffle partition should be this much only, it should not go beyond 200, then you can reduce the shuffle partitions. Again, this is the part of optimization. Then default parallelism. If you are working with the partitions means RDD and you whatever transformation you are doing, you are thinking that it should be defaulting to 100 partition, then you can go for sorry 100 parallelism. Then default number of the partitions in the RDD returned by the transformation. So here you can say spark.conf.set, then default parallelism 100. Then auto broadcast join. If you want to enable auto broadcast join, then you can give this setup and the threshold in bytes for broadcasting tables in join. This is the size you can increase or decrease. If you think that this can be the data size, this is the threshold value you in bytes or MB or GB you want to give. Then dynamic allocation. Dynamic allocation for the executors is sometimes we define the number of executor like this, where you are saying number of executor 1. Let's say I'm saying 10. That means it will be my application will be running with executor 10. Either all are occupied or not, doesn't matter, but that will be reserved. So sometimes we can keep dynamic one. Dynamic one means it will be looking, Spark will be looking out what is really required and according to the requirement that will be deciding for the executor score and all, and dynamically it will pick up. So we can think about that, but always that doesn't help. Sometimes Spark also can do something wrong and unnecessarily this will be getting some random numbers and that may not be good. And if that is good also, one can be more problem. Let's say I'm giving you a problem for the real time. Real time, let's say I have a job and I say I have a 100 node cluster. 100 node cluster. I am running for 50 GB. 50 GB data and I did dynamic allocation. Dynamic allocation and I started my job at 7 a.m. My teammates are starting they are having to they have to run 20 GB data. They need some 20 resources. Means they have given Spark this number of executor 20 and their job is to about to start at 10:15 a.m. As my job is running with dynamic allocation, Spark will understand that okay, you have 100 node cluster and let's make it 100 GB. It is thinking that if I utilize all 100 or let's say Spark automatically picked up 80 node. Because Spark is thinking to process this data as soon as possible. Okay, Spark started my job with 80 nodes or let's say 85 nodes. Something. Then and this job is about to start at 7:15 and this job is going to take around 1 hour to process with this much node. Just take it as example, random example. Don't think that this much node we need for this much amount of data. This is just example. Okay, So what do you think? This job will be starting and running at 7:15. This will run.
This will be in queue.
This will be in queue because this has blocked, right? This is a blocker now. Because Spark understood that if I am keeping this, this is fine, but this is not fine for another's. We are going to block another application. That is not a good practice. That's why always we should not choose the dynamic allocation. This is good, but always this is not good. This can be a blocker for another one, right? And again, instead of blocker, sometimes Spark is a machine. That's not a human being. Whatever we can think, our intelligence can't be matched with the machine. Simply, either this is OpenAI, artificial, DeepSeek, ChatGPT, whatever. They are what they are doing. They are doing whatever we have fed to them. They are scanning our previous data. All the data means they have been intelligent. All the intelligence, all the processing, all the learnings, whatever they have, that is based upon our previous data, history data, whatever we have fed, they are going through that. But they do not have anything new. What you are not feeding, what you are not making them, whatever you are, wherever you have not make them learn, you have not trained, they can't answer that things, right? They can answer only wherever training is done. Otherwise, they are unable to do. So our intelligence level can't be matched anytime with the machines. Machine will always remains machine, and humans are always humans. If we utilize our mind properly, that's the main thing. We should not be anytime dependent over any of the machines and all. We should utilize them, but we should not be completely dependent because we are always better. We can have some decisions and all which machines can't take. So for dynamic allocation also, Spark is good to take the decision, but always not required that Spark will be right only. Spark can be wrong. Okay. So, if possible, if you have good understanding, just to go with that. And in cloud level, we can think about some dynamic allocation, either in cloud or on-premise also. If you think that you are not sure how much data will be there and how much volume it needs, then let's keep the dynamic allocation. But you can come up with limitation. Limitation in the sense you can say, okay, dynamic allocation you are enabling, but you want to keep some max. That take max 30 only and take mean 15 only. Like that, if you are doing, then this you are making you know that it may take 15 also, it may take 20 also, 25 also, but it should not go beyond 30. So it is not going to block others, and as per the requirement this will be taking. But again, you should monitor whenever you are using this, that really this is doing well or not. Unnecessarily this is not allocating lots of resources. You should monitor. If you are sure that yeah, always this is doing good, then only you go with this. So this is really a good option, but you should make sure that everything is fine without any blocker and without any unnecessarily resources allocation. So for dynamic allocation, you can say the dynamic allocation true, and you can talk about this minimum and maximum, whatever I said. You can set up the boundary that min executor, minimum executor it can be 2, and then max executor it can be 50. So it will never go beyond 50 nodes. It will be going for the dynamic, but it will be having the numbers in mind that minimum I can take 2 and maximum I can take 50 only. Then max partition byte. What partitions you are enabling or it is having by default. For each partition, what is the size you want to allocate. So this is the size you can set up. Then open cost in bytes. Then estimated cost to open a file in bytes you can set up. Spark serializer if you want, which serializer you want to. So Spark is having Creo serializer, okay, the default one. Then memory fraction, then memory storage fraction. Then you can say about memory columnar compression if you want, you can enable this. Then in memory batch columnar storage batch size, then prefer sort merge join. So lots of settings are here you can see with whole stage filter push down. Then again for the parquet, for the ORC, for the hive convert meta store ORC. Then likewise, if you come down, then you have This one for the broadcast, local directory, task CPUs, then arrow and speculation. Okay, this is for the job is struggler. Sometimes what happens, job is stuck, means job is not failing, also job is not progressing, also job has been simply stuck, right? So that times we can make it speculation true. So it enables speculation execution to handle strugglers. If anything is getting blocked, then Spark will take care of that. That okay, if that is taking lots of time, so let's make the copy and run that with the multiple nodes and then process that completely. So I can say it in a small thing where it is speculation. So let's say you have a job that is running with 10 partitions. 9 partitions are done. One partition is running from last 1 hour and that is not moving, that is not failing also. That means that has somewhere hanged, kind of hanged, right? What Spark will do, if you have enabled, Spark will make some copies of the same job, let's say 4 copy or 10 copy, and that will get allocated to the different nodes, and it will see which is processing, and maybe all gets processed parallelly. So the same block is getting processed, same block or partition is getting processed with also node 2 also node 3 also, and node 1 completed in 10 seconds, node 2 completed in 5 seconds, and node 3 completed in 4 seconds. So which one is taking lots of time, that will be ignored, and which takes less time, that will be taken care. So we use speculative execution when job has a straggler, which is making tasks slowing down the execution and running in a multi-node cluster, and shuffling is having. Okay. So, let's say we are running a Spark job with 100 tasks. Let's understand this. You are running a job with 100 tasks simply. And uh, one task is stuck for 10 minutes due to data skew. Suppose some data skew happened and another task has been completed without speculation. The entire stage wait for the task. So let's say 99 tasks are done, but they will be waiting for one of the tasks that is hanged, right? That is struggling. So Spark will detecting the slow task which is slow, so it will be find that okay, one task is slow, and because of that all is in the waiting condition. So what Spark will do, Spark will launch a duplicate task on the different executor. Spark will not kill the task because entire application will be affected. Spark will make the duplicate task for the same, and it will launch over the another executor, and it will maybe one copy, two copy. You can again set up that with the configuration. And as soon as that task will get completed, this task will get killed down by the Spark. Because Spark is done. Spark has already completed this 99. For one only that is struggling. So for one, this will be allocating to the another node, and this will be waiting if that can complete the task at the earliest. And as soon as that will completed, this will be killed down. This is not needed now. Okay, because now this is plus 100 task got completed. So that is coming under the under this part, where if any job is task is struggled, then Spark will make a copy and allocate to another resources, and it will be completing the process with that new copy. It will avoid the older copy which is already stuck. Okay, and then that shuffle compression, if you whenever shuffling is happening, then you want to compress that, and dispelling the compression, RDD compression. Then here you have something like if you are going for some other serialization and file formats with the Spark SQL ORC window executor. This is for the window function, and then shuffling, buffering, pivot max values, and then adapt. Here you can see for the adaptive enabled, where you can enable adaptive query execution. Then along with shuffle, arrow, local shuffle, ignore corrupt files. If you are having some corrupt files, if you want to make that okay, that should be ignored while reading. So you can set up this spark.conf.set file ignored corrupted file. So this will be ignoring the corrupted file whenever you are reading. So all these configuration setups you can keep in the Spark. How you can keep below I have mentioned, like here you are creating the Spark session, right? So in the Spark session itself, you can go with all this setup. Here you can say .config shuffle partition 100 .config execute memory 4 GB. And then here is the Spark submit example. I have given all the things in the comment. You can take it. And then all the things like using a Spark conf, either you want to, or using environment variable you want to set up, or using properties file you want to set up. So how you want to set up all that parameters, all that configuration you can do using Spark conf, or in local cluster mode you want to set up, or in the Spark environment file you have environment .sh file, and there itself you can do like export this worker memory and Spark driver core, how much you want, how much size you want. If you are working with Hadoop, then using Hadoop core site.xml or HDFS site.xml, you can do the setup. So wherever is you are working, what is your requirement accordingly with the Spark conf, Spark session, you can make all these config setups done. Okay, and in which condition, which setup you are done, you need to do. These are some 50. I have listed down. These are something. You if you will do Google and all, maybe you will be getting 100 plus 200 plus. But I have listed whatever mostly we need. Okay, accordingly it is. So you can go through this. I will upload this document and you can take it and make sure that you are good with the optimization, because optimization is really required, and that is going to have a positive impression if you are explaining this very well in the interview. That's what I can say. And then I think that we are good with this Spark and all. Anyone? Okay, I think only two are there. Anyone is having any doubt or anything, or you think that something is missing here in the Spark and you wanted to discuss about that? No? Okay. Then for the next day, I will set up one a small thing just for the transformation level task, just monitoring. And after that, we will start with the database. Reading the data with the database and doing some transformation and loading to some target location. Simply, we are already done with the Spark, so we are not going to explore that. Just we are going to have one small uh, POC kind of things to just to treat as a data pipeline, building the data pipeline with multiple sources and targets. Let's say a database, you can have some NoSQL database, you can have a NoSQL database, you can have Kafka where we can evaluate a batch and streaming one. So in this weekend, just set up any of the database in your system, okay? So we can go ahead with that. Any question from anyone?
No.
Okay.
Anamika,
Yes.
is the database should be on the laptop or should be in a cloud one?
A database cloud one, you will not be able to do that because you need to make a connection, right?
Correct, huh?
So connection we can't build with the cloud one and all. Means the cloud means if you have cloud setup and you have their Spark session, Spark setup is there, and database setup is there, then it's fine. But if you are looking for just separate, then it's not okay. Like we were doing our exercises with Databricks, right? So this is our Databricks notebook. We were doing some exercises. I want to connect the database here. Uh, I never tried, but I think that I cannot connect because
Okay.
how I will be connecting my database here? That's the issue. But even you can try once. I have never tried, that's why I'm saying this. But if you have database set up anywhere, you can just try with the connection. If you can try out with the credentials, if you are good to connect, then it's okay. But I feel that we will not be able to.
Okay. Mm.
Okay, fine then. Let's meet on Monday. Have a good day. Bye.